Hello everyone. In this video, we are going to talk about the key design choices which you need to make when you build a scalable chatting application. Now, when you go online and search for the solutions, in most of the cases, what they will do is that they will use WebSockets for communication between front end to backend, and they will use Redis for the communication between the various backend servers. But it's important to know why it is so. Now, if you give someone answer in a meeting room or in an interview that, hey, we'll use Redis because somebody wrote online that let's use Redis. Or we'll use Redis because in all the places we have seen online, everyone is using Redis for a chatting application. It's a very embarrassing answer. You must know why you use a particular technology and not because somebody said so. In fact, WebSocket is counterintuitive because in most of the cases, whenever we build solutions, we build using HTTP or gRPCs. And likewise, for backend to backend communication, in most of the cases, we call the synchronous API, possibly the HTTP API, the REST API or gRPC APIs, or the connection using WebSockets. So when someone is communicating using real-time communication, that is Alice wanting to send message to Bob, she sends message to backend, backend sending message to here, and then Bob getting message. This should be synchronous. Why pub-sub model? So a lot of questions are there which should be answered, and that's what we'll do in this video. We'll compare various options which we have, and then we'll reject the other solutions so that you can properly justify why Redis or why pub-sub model in the first place. Likewise, why WebSocket, and then we'll come up with a solution. So let's quickly get started. This is the problem statement. You have Alice, you have Bob, and you want them to communicate with each other. So here you have the front end layer. The front end layer would be written in JavaScript or some front end technology, and it will be running on a browser, and the backend servers will be hosted on cloud on the virtual machines. So when they communicate with each other, you can clearly see that one machine would not be enough. So if your system is small to handle all the user sessions in just one single machine, in that case you might as well live with that. You will have just one backend machine and you will have multiple users connecting to the same machine. I have already posted a video a couple of weeks back. I'll link to the video so that you can see how a system works when there is just one backend machine. But you can see if the system is large enough, then you would need multiple backend machines. And in that case, different users will be connected to different machines. So Bob would be connected to backend 1, Eve might be connected to backend 2, and still they would want to communicate with each other. So your request might go here to here and then here. So that's the first thing. You might also want to ask me the question that, hey, this is not the complete system design of WhatsApp. Where is authentication? Where is load balancing? I agree, but I'm not going to mix the discussion of load balancing or reverse proxy or the authentication or authorization in this video. I'll specifically focus on how the network communication happened, how this Bob communicates to backend and this backend communicates to backend too. So overall two layers, one is the front end layer and the other is backend layer. First category is communication from front end to backend, and the other category is communication between the backend machines. So we'll start with the first category, that is how would front end communicate to backend, what technology they will use. So let's see that. So if you see front end to backend communication protocols, so there are many of those protocols and many of the methods using which the front end world can communicate to the backend. The most popular being HTTP and HTTP long polling. They were being used in the past a lot. So we can see one by one. If you see WebRTC is very popular in having a communication based mechanism. If you search online, you will see that many of the real-time chats and the video call are based on this WebRTC. However, when you dig deeper into it, you will find that WebRTC has better use case in case of video calling or audio calling. You can definitely have a text based chatting as well in WebRTC, but most of the service provider, they don't choose it. They see it as a engineering overkill. And honestly, WebRTC is a little complex technology if you compare WebRTC with other solutions which are available. So for the chatting application, instead of WebRTC, it's better to go with the other solutions. So if you see long polling or HTTP polling, so this means that the browser will keep on polling the backend every 2 seconds or 3 seconds to see, hey, is there any new message for me? Then next second again polling to backend, is there any new message for me? It's also very inefficient, and eventually it will make the system very difficult to run, because there will be so many users, these so many front-end machines who will keep on polling the backend to ask, is there any new message or not? And HTTP comes with a lot of headers as well. So if you see a request body or the HTTP request in your postman or something, you will see there are so many extra parameters which are sent in HTTP. Likewise in HTTP long polling as well. So again, it's less performant because you poll the server, and then the front end will wait for the backend to get the data, and that long polling can go as high as 30 seconds or even 1 minute. So till 1 minute, the thread will be clogged. So it's inefficient way. And in fact, in HTTP, what happens is that first you establish a connection, and then you get a data, and then you break it. So overall in HTTP, there are 3 steps. Whereas if we come to WebSockets, it is the most common solution for the real-time chatting, because in case of WebSockets, what you do is that if you have a client and you have a server, then what you do is that you establish a TCP connection. And then once the TCP connection is established, you live on that TCP connection. So that connection is established till eternity theoretically. It will not break unless there is some network issue, or if one of the front end or the backend machine breaks the connection. So the overhead of connecting to backend is just once. And once the connection is established, all you need to do is send message and receive the message. So WebSocket is bidirectional. I have explained this topic as well in the other video which I have linked. So definitely go out and check it out. So in this way, we can establish that WebSocket would be the default choice for front end to the backend communication. Now, if we move towards the backend machine to backend machine communication, then there are principally 2 options. One is the synchronous calls, and the other is asynchronous calls. The synchronous calls can be done using the REST calls, gRPC calls, or even WebSockets. And the asynchronous calls are something which could be done using pub/sub model. So you produce a message to a particular channel or topic, and you get the message from there. Now, this one is something which is very popular. The other one is also popular, but there has to be a specific use case when we use this. So the first problem with the synchronous model is that all the backend machines will not know the address of the user where he or she is connected. So for example, a user who is connected to backend 3 machine wants to send message to somebody on backend 2 machine, or let's say Raj wants to send message to Rahul. How would backend machine 1 know where or in which machine Rahul belongs to? The problem here is that the connectivity to the machines can keep on changing every day, or even after a few hours as well, because these are the machines which will keep on dying and the new machine will keep on coming up. So you cannot bind a user to a particular machine to which that user is connected to. It's not the persistent layer. It's processing layer where the user is connecting to get data from backend. So these machines would keep on dying. The deployments will keep on happening. So it's very hard to keep track where the particular person belongs to. So if you send a message to Arjun, you would not be sure where Arjun belongs to. You can handle it, but again, it will add the complexity part. The second is that the acknowledgement from the services will take time. So if somebody wants to send message to two people and in one go, so they need to wait from both the servers. And God save us if one of the server is dead or the deployment is happening on that server. In that case, the whole ACK or the acknowledgement to the caller will be slow. And also, if there are multiple servers, how do you handle the case of partial success? So what would happen if you want to send message to two people and one server is dead and other is alive? How do you retry? Because everything is synchronous. So you would have to reply back to the caller that, hey, I tried to send message to two people. One of them was alive. So I sent that person message, but I was unable to send to other one. And there is no mechanism to retry. What if their internet was off? So you can't do that. Whereas in PubSub model, it becomes more fault tolerant. If person is not connected to internet or the person is not able to consume the data, those data can be put to a queue and eventually put to a DB so that when they come up, they can get the data. The second is that the server does not need to know the address of everyone. So if a new backend service joins, because this keeps on scaling, so these servers do not need to bother about the new machine. They just need to publish the message to stream and the other service would just consume it. So knowing the address of other people is something not desirable and you don't need to do it here. So you are safe in terms of scalability as well. You keep on adding machines, you don't need to bother or change anything in this machine. And the third is that the acknowledgement part. The publishing of message can be done to a topic, and then if there are multiple receivers who should receive that message on different machines, they don't need to think much. They just need to consume from the particular topic. So overall, PubSub model will help you more compared to this one. This will make your life very difficult because you have to keep track of so many things. But here you just publish to a queue and then get the data from queue. So overall, a better method of communication compared to the regular API calling or the synchronous methodology. So overall, this is how your solution will look like. That is, Alice will connect to Redis and Bob will also connect to Redis. Now there is one interesting thing which you will see is that there are two connections which are established instead of one. That is one connection to publish and the other to subscribe. That's how the design of Redis is, that you need to have two connections. If you have subscribed using one connection to Redis, so you can't publish using that connection. So overall, each machine, each user would need to have two connections. One is to publish and other is to subscribe. So this is how it will look like. If Alice wants to send message to Bob, Alice will publish the message to Bob's mailbox or Bob's channel. And then since Bob has subscribed to his own channel, he will get the message. Likewise, when Bob wants to send message to Alice, she will publish or he will publish the message to Alice mailbox or Alice channel. And since Alice is subscribed to her channel, she will get message. So likewise, the decoupling will happen, and this is the overall system which will look like. Now there is one more important discussion or the design choice, which is slightly nuanced. So there are two ways using which you can connect or you can subscribe to the channels in Redis. One is that you subscribe to your own channel, that is subscribing own channel and publishing to others channel, and the other is subscribing to other channel and publishing to own channel. Now the thing is, till now we have justified that hey, pub/sub model is good, let's just use pub/sub model, but that is not enough. What will happen if you explain to someone or if you get deeper into it, this will be slightly confusing as well, because either you can do this, you can subscribe to other channel. For example, Alice can subscribe to Bob's and Eve's channel, and if someone wants to send message, they can send message to Bob's channel that hey Bob, this is the message, and Alice can subscribe. The other way around is also true. Now this approach is much better compared to this approach, that is people subscribing to their own channel and publishing to other channel. The first thing is that all these subscribers, all these people, they just care about themselves. Here they care about others. So the problem is, number one, principally it destroys the principle of a single responsibility. Now Alice is coupled with Bob, Eve. Now tomorrow if some other guy joins this system or takes the subscription of this system, now all the other people would need to subscribe to one more person. So till now it's Bob and Eve. Tomorrow let's say some guy named Arjun joins the system. So all these people have to modify it. And who will tell them that this new person has joined? And how many subscription are you going to add? Maybe this person who has joined, he is so introvert, he is not going to talk to anyone. Now, since this person is not going to talk to anyone, why would you have one extra subscription alive all the time? So if a new person joined the system who is introvert, let's not even subscribe to that. And we can have things on demand. So any new person joining will just clog the whole system. Whereas here, if a new introvert guy joins the system, all he will need to do is to subscribe to his or her channel. That's it. So not coupled. The second is that, yeah, the list of the subscription do not change. That is, this person is subscribed to her own channel, whereas here the list will change, and it's very hard to change such list. Think in terms of the scale of what the chatting application can become. Would you really have a long list of subscription? No, not really. It's not possible. And the third is that this one is more secure. So for example, Alice is able to read her own message. Bob is able to read his own message. So here Bob can write to Alice's mailbox or Alice channel that hi Alice, how are you? Eve would also send some message to Alice, but the permission to read the data is only for Alice. So Alice owns her own mailbox. Alice is the only person who would be reading her mailbox. Other people would just be publishing to Alice's mailbox. Whereas here, if you have a long list of people, you might end up making that mistake that, for example, if Bob gets message from, in the mailbox, Bob might have to check which of these messages for me. So any small coding mistake can just ruin the whole system. So this is not a good choice. Instead, this is a good choice, that you subscribe to your own channel and publish to others' channel. So you can write to others' channel. If you want to send message to Bob, Alice will publish to Bob's channel and Bob will get the message. But you subscribe to your own. In this way, the system will keep on scaling and will be a better system overall. So this is how the overall system will look like. That is, you will have multiple users. These users will be connected using browsers, and these users will be connected using WebSockets. So WebSocket will be a perpetual connection. That is, once connection is made, Now the only thing needed is to transfer the data. All the TCP handshake, all the authorization, those things are done. Once they are done, the only thing you are needing to do is to send and receive the message. That's it. So this will be a very lightweight sending and receiving of the message. Likewise, there will be two connections being made for each person. One is for publish and the other is to subscribe. The publish connection would be something which would even die, because you don't even, you can reuse among multiple people as well, because these people will not always be talking, but subscription is something which will always be alive. So two connections will be made, one to publish, one to subscribe. Likewise here, one to publish, one to subscribe, and these all are TCP based connection. So at the network layer, the protocol defined by Redis is TCP. They have some layering on top of it for the application layer, but that's what they use. They use TCP to connect to the Redis. So WebSocket connection here and the TCP based connection here. Backend machines can keep on getting scaled, no issue here. People can keep on adding the backend machines as and when these users increase. And this Redis is also scalable. So there are a lot of documentation around it. I might cover specifically around Redis in the future, but you can take it that Redis is also scalable. So you are publishing data to Redis and you are able to get data from Redis. So all the layers are overall scalable. There are in between load balancers or reverse proxy, but I'm not covering them because I completely wanted to focus on how the communication will happen, how these various layers will communicate, and answering various questions. That's all from my side for this video. Please like and comment if you really like it. It really makes a difference. I'll keep on posting such video every week. Till the next time, bye.